Now we will try to achieve the first goal, which is mutual exclusion. So we'll try to achieve our first goal known as mutual exclusion. So at first we will learn about some hardware based solution. Some hardware based solution. So let's say our goal is to provide mutual exclusion. We'll consider our trial room example. Let's say you are in the trial room. So one customer is using the trial room. In this meantime, we cannot let others to access the trial room. This is mutual exclusion. If one person is accessing that critical section, no other process can access it. So here trial room is the critical section. Everyone wants to access it, or it is the shared zone. So if one customer is accessing the trial room, other customers will be blocked to access the trial room. So how to do that? So the easy way is whenever the trial room is empty, the door will be open. So the door is open, so someone enters the trial room and it locks the door, and he or she locks the door. So if there is lock in the trial room, that means other customers will understand that the room is occupied. So we will need to use a lock system. So whenever you access a critical section, then you will lock the solution. Sorry, lock the entry. So that means no other processes or no other customers can enter the critical section. So you enter the trial room and you lock the gate. So now the hardware based solutions are based on the premise of locking. Actually, we will implement this locking mechanism in the processes also. Okay. So let's say we are in a single processor environment. So this year's problem can be solved by preventing interrupts from occurring while a shared variable is being modified. That means, let's say you have a single processor, two processes are running concurrently. That means any processes can be interrupted during its execution. So whenever they are being interrupted, we saw there is a data integrity problem. So one of the solution can be we cannot interrupt others. So we'll prevent interruption. So if we prevent interruption, they will be executed sequentially. Then there will be no data integrity problem. And but this is tricky for the multiprocessor environment. So it wastes a lot of time if we stop interrupting. So we'll see another two example: test and set, compare and solve. So here the problem was if there are multiple processes running concurrently and they are sharing some variable, so while modifying them concurrently, there may be a data integrity problem. So one way to solve it is if we stop interruption. But this is tricky for multi-processor environment. So now we will see some hardware-based solution. How can we solve this problem? So this is the based on locking mechanism. These solution are based on locking mechanism. That means whenever you are accessing some critical section of your program, then you will lock the entry so that no other process can enter it. So now we will learn about test and set. So these are hardware based solution. There are a code name uh, test and set. This function or this code is executed atomically. This code is executed atomically. That means test and set function is executed automatically means while executing this block of code, you cannot interrupt it. While executing this block of code, you cannot interrupt it. That means once it starts executing, it will complete its execution. In between, they can't be interrupted. So this is known as atomic function. So test and set is a atomic function. That means you will learn them. You can execute them at once. So what is the operation performed within test and set? It takes a value. It takes a value. Let's say its name target. It saves its previous value. Then it assigns true to target and then returns the previous value. Here it takes a boolean input, a boolean parameter. That means the value of target can be either 0 or 1. It saves the previous value of target. Let's say the value of target is 0. So the return value is 0. Then it sets true to target. That means true means 1. So current value of target is 1. Then it returns the previous value. That means it will return 0 as RB is equal to 0. If the value is 1, if the value is 1, so if the value is 1, the RB value of RB is 1, then target is equal to true, that means 1, and it returns RB, that means it will return 1. So using this function test and set, we can achieve mutual exclusion. We can achieve mutual exclusion. Let's say this. So how to do that? So let's say you have a trial room. Initially it is open. So lock is equal to false. As it is open, lock is equal to false. Then at first one customer comes. Here customer are the representative of the process. One customer comes. At first it will check the trial room is engaged or not. That means anyone is using the critical section or not. So here trial room is the critical section, customer is the process, and there is a lock function, a lock variable. Initially the lock is equal to 0. So it will check. So it is, let's say it is customer 1 C1. It will check the trial room or the critical section is engaged or not. So while test and set lock, so it will check. So using the function test and set, it will test the trial room is engaged or not. So what is done here? The value of log will be sent here. So initially the value is false. The value is false. Then the value of RB will be false. Then we will set the value true, target true. You need to understand start target is the log variable. So you already understand the concept of pointer. So start target and log are the same, pointing to the same memory address. So start target and log is similar. So the value of start target is true. That means log is equal to true. Then return RB. It will return false. So while false, while the condition is false, then it will exit from the while loop and it will access the critical section. That means the customer comes, checks lock is true or false. Initially it was false. That means the trial room is free. It will enter the trial room, and before entering the trial room or before using the trial room, it will close the door. That means lock is equal to true. It will close the door. That means process 1 or customer 1 is using the critical section or the trial room. So let's say customer is using the trial room. Now another customer comes. It is customer 1. Now another customer comes, which is customer 2. So it will again check this condition, the trial room is engaged or not. So it will send the value of log to the test and set function. Currently the value of log is true. So here true will be sent. The value of RB is true. Then target is equal to true. That means log is equal to true. Then it will return RB. That means true will be returned. So while true, that means while condition equal to true, it will do nothing. While condition is equal to true, it will do nothing. While here condition is true, that means it will wait in this scenario. That means it founds that lock is already true. That means the door is closed. That means the critical section is being used. So it will do nothing. So in this way, we can achieve mutual exclusion. For example, C1 is using the critical section, C2 is blocked from using the critical section. C2 is blocked from using the critical section. So C1 is using the critical section, C2 is stuck in this while loop. C2 is stuck in this while loop. Now, after some point, C1 will exit from the critical section. So before exiting, it will, this is the exit section. So before exiting, it will make the lock false. That means it will open the door again and come out of the trial room. So the value of trial is equal to, lock is equal to false, and it will execute the remainder section. Now C2 again check this. C2 will again check this. Now C2 will come. C2 will come. It will pass the lock variable here. The value of lock is false now. So RB is equal to false. Target is equal to true. Then return RB. False is returned. So while condition is false, that means it will come out of the while loop and it will access the critical section now. So if C2 comes out, C1 comes out, C2 can access the critical section now. So in this way, using test and set, you can achieve mutual exclusion. That means whenever a process is accessing the critical section, other processes is blocked from entering the critical section. Okay, so before accessing the critical section, you need to check the value of lock. If lock is false, that means the resource is not engaged. So you keep the access, or you acquire the access. That means lock is equal to true. That means you closes the door, and you will using the critical section. While you are using the critical section, every other processes will be blocked from accessing the critical section because lock is false. While lock is false, you are stuck in this while loop. So in this way, you can use test and set to achieve mutual exclusion. There is another hardware based solution which is known as compare and swap. So this is also a atomic operation. That means whenever you are executing compare and swap, you will not be interrupted. You will not be interrupted. So in test and set, there is only one binary variable. Either it was 0 or it was 1. The compare and swap works like this. It takes a value, then it takes another expected value and another new value. Initially, it stores value, the previous value of variable value. Then, if the previous value is same as the expected value, then it will assign the new value to the variable. So, if they are equal, then you will assign the new value here. Then it will return the previous value of, let's say, it is bar. There is a variable bar. So it will store the previous value of the variable. Then if the value of current, if the, sorry, it will store the current value of variable. Is the current store the current value of variable in temp. If the current value of variable is same as expected, is equal expected, then we will assign the new value to the variable. Then finally we will return the value of temp or the previous value of var variable. So in this way, the compare and swap works. It compares the value with a given value. If this is true, then it will swap with the new value. Swaps the value, the new value. So using this method, you can also achieve mutual exclusion. So again, there is a log variable. Initially it is 0. So we will check. Our expectation is the value of lock will be 0. That means the door is open. If the door is open, I want to acquire it and I will close the door. That means lock will be 1. The lock will be, the value of the lock will be 1. So that means initially it is our trial room. The door is open. That means lock is 0. We didn't lock the door. We expect that the lock is 0. That means the door is open. If the door is open, we want to acquire the trial room. That means we will lock the door. So everything is like test and set, but it gives you more flexibility to use different kinds of expected and new value. So compare and swap is also like the test and set, but it gives you more flexibility because you can set any expected value or any new value here. So we expect that the lock will be open. That means 0. If the lock is open, then we want to acquire it. Then the lock will be 1. So that's how you can use compare and swap. So here is a task for you. use compare and swap to implement test and set. So using compare and swap, you need to implement test and set behavior. So here is it is given, but here is the task. Uh, so if you use like this, this works like test and set, but you need to understand it. This is the home task for you. Let's go through it. You will understand how this works. Okay. Now, so we saw two hardware-based solution. In the hardware, you have this methods implemented or for your support, test and set, and compare and swap. But as for the application level programmers, using this method is not quite so friendly. So we will explore some software-based solutions. We will use some high-level software-based solutions. The hardware-based solutions are good, but for the application-level programmers, they are not so convenient for them to use. So now we will use some high-level software tools like mutex lock to achieve mutual exclusion. So we didn't achieve the other two properties, progress and bounded waiting. They are a solution uh, for this. How to achieve this? So you, in the testing set or compare and swap, you can also in your code you can also achieve bounded waiting. So in your book it is given, so you can self study it. Now we will learn about mutex lock. So it is a software based tool to solve the CS problem. CS means critical section problem. So one of the tool is mutex lock. Mutex means mutual exclusion. Mutual exclusion. Mutex. Mutual exclusion. So these are the software based solution. You need to remember these functions are atomic functions. That means while you are executing this code block, you can't be interrupted. Okay. So to acquire a log, to acquire a critical section, there is a function named acquire. To release a resource, you have a function called release. That means before entering the critical section where you are modifying some shared value, before modifying the shared value, you need to acquire it first. So you will use the acquire function. Then after using the shared variable or shared resources, you need to release the log. Okay, so that others can access it. So how the acquire function works? So there is something called available. There is something called available. Every time we check the resource we want to access is available or not. Here the resource is our trial room. So every time we will check the trial room is available or not. If available is equal to 1, that means the trial room is available. If available is equal to 0, that means the trial room is not available. So every time we will check the trial room is available or not. So in the acquire function, so before accessing the trial room, you need to acquire it. Before using the trial room, you need to acquire it. In the acquire function, you will check the trial room is available or not. While not available, if the trial room is not available, while not available, this is the not sign. While not available, if the trial room is not available, we will wait. We will do nothing. We will do nothing. We will stuck in this while loop. While not available, every time we will check the resource is available or not. If not available, we will stuck in this while loop. After a certain time or certain period, it will be available. If this is available, then we will acquire it. As we acquire it, again the available will be false. As we acquire it, again the available will be false. So now we acquired the critical section. We will use this critical section. After using the critical section, we will need to release it. So when we release the trial room, and it will be available again. That's why in the release function, available is equal to true. That means others can access it now. So every time we will check the trial room is available or not. If it is not available, we will wait. We will do nothing. After some time or after certain period, it will be available. Then we will acquire it. As we acquire it, it will not be available for others now. So that's why available equal to false. Then we will access the critical section. Then after using the critical section or the trial room, will come out and make the resource available for others. So that's why available is equal to true again in the release function. Okay. So in a program, so there is the, this is the entry section, this is the critical section, this is the exit section, and this is the remainder section. So in the entry section, you try to acquire the resource. In the entry section, you try to acquire the resource. So that's why the acquire function. After acquiring it, you will run the critical section. After critical section, you will exit. That means you do not need the resource now. So that's when you call the release function. After that, others are the remainder section. Okay. So these functions are also atomic. So you cannot interrupt them in between. So okay, there is a code example for you. And so let's say there is two thread T1 and T2, and there is a value sum. Sum is equal to 0. So both of the threads are calling the function func thread. It is also using the func thread. In this func thread, uh, for I is equal to 0 to 2, it is incrementing the sum value. For I is equal to 0 to 2, it is also incrementing the sum value. Here sum is a shared variable. Thread T1 is also modifying the sum variable. Thread T2 is also modifying the sum variable. So here sum is equal to sum plus 1 is the critical section. In this section, they are accessing and modifying the shared variable. So for T1, it is the critical section. For C2, it is the T2, it is the critical section. So we saw that if two processes or two threads are running concurrently, there can be a data integrity problem. That means depending on the order, the value can be different, and it is not a consistent value, or it is a false value, or it may be a false value. So before executing the code, you need to protect them. So we will try to achieve the mutual exclusion here. Whenever we will access the critical section problem or the critical section code, We will acquire it first, then we will access the critical section, and then we will release them, such so that T1 and T2 do not modify the same variable or the same shared value at once. So how to do that? So initial code is easy. You created two threads, T1 and T2. T1 is executing thread, a func thread. T2 is also executing func thread. In the thread chapter, you already learned how thread works. So in the thread code, they are running like this. They are initially you ignore the red color boxes. So in the thread function, so for I is equal to 0 to 2, it is incrementing the sum value, then returning the sum value. So this is the code. So if you convert them in low level code, that means what we saw in the data integrity problem. So there is multiple instructions for this single instruction. So there can be the data integrity problem. So before accessing this code, at first you need to understand there is some data integrity problem. How we understood it? There is a shared variable sum is equal to 0. Then we saw T1 and T2 are running concurrently, and in each of its code they are modifying the same shared variable sum is equal to sum plus 1. So there can be a data integrity problem. So that's how you detect a critical section problem. So where there is a shared variable and one or two threads, sorry, more than one threads are accessing the same variable. So whenever they are accessing the same variable, this is known as critical section. So you need to satisfy the requirement to solve a critical section problem. So what are the solutions for mutual exclusion? So we saw two hardware based solution. Now we are using the software based solution, which is mutex lock. So before accessing the critical section problem, critical section of code, you need to acquire the code. You need to acquire the critical section. So how to do this? You need a mutex. That means before using sum is equal to sum plus 1, you need to acquire it. And after using sum is equal to sum plus 1, you need to release it. Okay. So here before sum plus 1, there is the acquire function, and after using sum equals sum plus 1, there is the release function. So you take a value mutex m, you initialize value mutex m is equal to null, then you use mutex lock. Mutex lock is the function from the POSIX library. It is equivalent as acquire. Mutex lock is equivalent as acquire, and you enter the critical section and execute the critical section, and then you mutex unlock. Mutex unlock is same as release function, and mutex unlock is from the POSIX library. After that, you join the thread code and destroy the mutex. As you do not need it now, you can destroy it. So basically the key point is whenever you are using or you are modifying the shared variable, you need to acquire the code. So such that mutex or mutual exclusion is confirmed. Okay. So whenever there is a shared code, you need to use mutex lock. And after accessing the shared code, so shared variable, you will mutex unlock it. That means it is the acquire and release, equivalent of acquire and release. So I hope you got it how to achieve mutual exclusion whenever you are modifying the shared variable. Okay. So how to detect a critical section problem? There will be a shared variable and more than one processes will be modifying them at once. So here T1 is modifying the sum variable, T2 is also modifying the sum variable. So this is the critical section code. So there can be multiple critical section. So for each critical section, you need to use different mutex log. Okay, there may be multiple processes or multiple threads. You need to use different mutex log for different critical section. So in this way, you can use mutex to achieve mutual exclusion. Okay, this is the output of this code. Now we will learn about semaphore.